In this video, we have our third part of Coulomb's law, where we're going to talk about its implications for lattice energy. First, we have to define lattice energy, but I want to put the kind of warning out there that this is extremely conceptually similar to ionization energy, and students have been confused in the past, so make sure that you try to file these in the separate parts of your mind. Lattice energy is the energy necessary to separate ions that are attracted. So instead of pulling an electron off of an atom, pulling away subatomic particles that are attracted, here we're going to talk about how much energy would it take to separate an Mg2 plus ion from an O2 minus, compared to how much energy would it take to separate lithium plus from fluorine minus. To do this, we're going to use our simplified Coulomb's law, right? And we're going to get some numbers that we can relatively compare to answer the question of who has the greater lattice energy. So for Q1 and Q2, in this case, it's different than when we talk about ionization energy, because the Q1 is not the effective nuclear charge, it's the charge of the positive ion. And Q2 is not 1 anymore. We're not talking about the charge of an individual electron. Instead, we're talking about the charge of the negative ion. Now, typically, when we talk about this, we're going to be talking about the distance between both of the nuclei. So, magnesium is in the third period of the periodic table, all right next to sodium, but it becomes +2, and when it does that, it adopts the same electron configuration as neon. And that means that Mg2 plus only has 2 energy levels, not 3. And oxygen started with 2 energy levels, it gained 2 electrons, it also looks a little bit like neon in terms of electron configuration, and it has 2 energy levels. So we're going to call this 4 energy levels between the nuclei. And we get this number. Again, what does this number mean? Nothing, right? It doesn't really mean much. It only means something when you compare it to another number. So let's do the same thing for lithium fluoride. Lithium has a charge of +1. Fluorine has a charge of -1. Lithium is in the second period of the periodic table, so it has 2 energy levels to start when it's neutral, but it loses one of those and only has 1 when it's +1. Fluorine minus has 2. So the total is going to be 3. There are 3 energy levels between the nuclei. (1/9). Now, we can compare these two numbers and see that 1/4 is greater than 1/9. And all that means is that magnesium oxide has a higher lattice energy than lithium fluoride. Magnesium +2 and O2 minus would be more difficult to pull apart than lithium and fluorine.